In this chemical equation, we have chlorine gas reacting with lithium iodide and producing lithium chloride along with iodine. So we're going to start by determining how many atoms we have. We have 2 atoms of chlorine. We have 1 atom of lithium because there's no coefficient plus there's no other subscript. So it's understood to be a 1. The same thing with iodine. On the product side, we have 1 chlorine, 1 lithium, 2 iodines. Next, we need to identify the loner, and that is the one that is not part of a compound. Also, at times there can be more than 1 loner, such as like what you're going to see in this case. So the ones that are not part of a compound are chlorine and iodine. The loners, we leave them, we try as possible to leave them towards the end. We balance them towards the end, if possible. Next, we need to identify the 1:1 ratio, and that would be the one that appears one time in the reactant side and one time in the product side, and it doesn't matter if the subscripts are different, and they can be part of a compound. So chlorine, it appears one time in the reactant side and one time in the product. The same thing with lithium and the same thing with iodine. 1 and 1, 1 and 1, 1 and 1. Next, we need to start with the largest 1:1 ratio, and this would be the one that has the largest subscript. So out of the ones that we put the check mark, the ones with the largest subscript are chlorine and iodine. And it doesn't matter with which one you start. In this specific case of this chemical equation, notice that the loners, we usually try to leave them towards the end. But since this chemical equation is a little bit different, we're going to have to start with one of the two because they also happen to be, in this case, one with the largest subscript. So you can start with either or. It's still going to give you the same answer. So I'm going to start with chlorine. I'm going to log this in with a 1. So 1 times 2 gives me 2. So therefore, I need to have a 2 over here. So I'm going to erase this. And I'm going to write a 2 here in the coefficient. Therefore, I now have 2 chlorine atoms on both sides. When I wrote this number in the coefficient, it also locks in the lithium. So I now have 2 lithiums. So if I have 2 lithiums in the product side, I need to have 2 in the reactant side. So I'm going to come here and I'm going to write a 2. Now that I wrote a 2, in this compound, it also locks in the iodine. So 2 times 1 gives me a total of 2. So if I have 2 here, I also need to have 2 in the reactant side. So I'm going to write a subscript of 1 because 1 times 2 gives me 2. And at this point, everything is balanced.